That's the end of the section on how forces change shapes. This section is about distance, speed and acceleration. Before we start, let's be sure exactly what we mean by speed and how to calculate it.
I think we should look at exactly what speed is. Now, our speed tells us the distance we've travelled in a certain time. And the faster the speed, the more ground we cover each second. So, to be able to work out our speed, we need to know the distance we've travelled and the time taken to cover that distance.
But how can you tell if a car's speeding? Would you just guess?
Oh, no, we don't guess. I have several methods open to me. I have a speed gun, I have fixed cameras at the side of the road, and we have a time and distance computer.
To calculate the speed of a car, Tom needs two measurements: a distance the car has travelled and the time it took to cover that distance. Tom can use the computer to measure the distance between these markings on the road and the markings under the shadow of the bridge. And then all he has to do is time how long it takes a car to travel between the two marks. Dividing the distance by the time gives him the car's speed.
We've put in 105, which is the distance measurement, and now on this side we're going to use the stopwatch side of it, and we're going to time the vehicles travelling between the white paint marks and the bridge.
Black car in the outside lane. I don't think it's going that fast. Let's see.
No, nor do I.
Here we go.
The shadow, that's it.
Now, to get the speed, all I have to do is divide the distance by the time the car takes to cover it. Luckily, the computer does that for me.
49.93.
Oh, you were lucky.
Just within the limit by 0.7 of a mile an
You
hour.
were lucky.
Another way Tom can measure speed is by using roadside cameras, which are triggered by cars going too fast. And the double flash and the markings on the road are a clue to how they work.
Each site has calibration marks laid on the road surface that are 2 metres apart. Now, when a car comes along and triggers the camera and has a photograph taken, it automatically takes a second photograph half a second later. Now, all we do is put our finger on the mark there where the back wheel is, move on to the second photograph and count how many squares the vehicle has travelled in that half second.
OK, so that's 1, 2, 3, 4, 5. Now, they're 2 metres apart, is that right? So that means in half a second that car has travelled 10 metres.
That's correct. And then we look on the chart behind us and we see that metres travelled 10 and half a second equates to 44.7 miles an hour. Now that's nearly 45 miles an hour, and we will send this motorist a notice of intended prosecution.
This man means business.
So speed is distance divided by time. The unit of speed is metres per second, kilometres per hour, or miles per hour, depending on the units of distance and time being used. If speed equals distance divided by time, and you know any two of these values, you can work out the remaining one. Distance equals speed multiplied by time, and time equals distance divided by speed. If something doesn't travel at a constant speed, it must be getting faster and faster or going slower and slower. Accelerating is the word for getting faster and faster, and decelerating is the word for getting slower and slower. Acceleration, or deceleration, is the rate at which the speed is changing. There's more about distance, speed and acceleration in the higher tier programme. That's the end of distance, speed and acceleration.